Dr. Harsha, can we start now?
Yes, we can.
Yeah, okay. Uh,
We have
hello.
more than 200.
Yeah, more than 200. Yeah. Hello and good afternoon to all, ladies and gentlemen. Welcome to today's webinar for this very special talk on Howrah Bridge, the awe-inspiring icon of the city of Kolkata. And this will be done by one of the eminent personality in the field of structural engineering, Mr. Amitabha Ghoshal, who is also the president of Consulting Engineers Association of India. I am Alok Bhamik, and I am the president of Indian Association of Structural Engineers and the host for the webinar today. Uh, for those participants who may not be aware of our association, let me just briefly mention that IAStructE, that is Indian Association of Structural Engineers, is a national apex body of structural engineers in India, established with the objective to cater for the overall professional needs of structural engineers. If you want to know more about our association, I would suggest that you go through our website, which is iastructe.co.in, and you will get more details. The webinar today will be moderated by Dr. Harshavardhan Subbarao, a very dear friend of mine and a learned friend. He is the chairman and managing director of a very leading consultancy firm called Consumer Consultancy. He holds a PhD from Imperial College London. He is a governing council member of our association, and also he is the vice president of International Association of Bridge and Structural Engineers, Zurich. Just to give you a little more brief about Dr. Subbarao, he has been involved with several landmark projects, such as Signature Bridge, Cable State Bridge, Signature Bridge in Delhi. Uh, then this Railcom Road Bridge, Patna. He has also been involved in several repair and rehabilitation of bridges in India in various forms: steel, concrete, composite. He is a member of the technical committee of YAPSE, Zurich, chair of Bulletin Edit Board, member of FIB Commission on Durability and Service Life Design, member of the Highway Research Board of India, and serves on several committees of Indian Roads Congress, BIS, and various international national bodies. He has over 30 years of experience and a number of papers and bridge projects to his credit. He is a very active member, let me tell you, of several code committees in which I am also his colleague. This webinar is about the story of Howrah Bridge, which is the first long span bridge in India. This iconic bridge serves as the gateway to Kolkata, connecting it to the Howrah station, which is one of the five intercity train terminus stations serving Howrah and Kolkata. Many people, I'm sure, knows about the bridge, but very few knows about its interesting history. And today we have the storyteller, as I mentioned earlier, who is Mr. Amitabha Ghoshal, and an eminent personality in the field of structural engineering. I don't think anybody else knows as much about this bridge as Mr. Ghoshal does. Before I hand over this floor to Dr. Subbarao for conducting this webinar, I have some information to share with all the participants. Firstly, about a lecture course that we are organizing from 5th of September. IAStructE is organizing a lecture series on cable stayed bridges, which will be delivered by Professor Holger Svensson, a German expert, a professional, and an author of a famous book on cable stayed bridge. This will be done every Saturday and Wednesday from 5th of September till 17th of October. That means there will be 14 working days and every day 2.5 hours from 4 p.m. to 6:30 p.m. for next 6 or 7 weeks. This 90-minute lecture every day will be followed by about an hour of panel discussion and question and answer session. Uh, Before I hand over this mic to Dr. Subbarao for moderating, I wish to thank all the participants for attending today's webinar. We have a registration of more than 1350 people, and so anybody who is not able to log in can also, it is also sort of live programmed, so you can connect directly live. I also would like to thank Mr. Ghoshal profusely for the fact that despite his very busy schedule, he agreed to deliver this lecture, just requesting him once. And I'm thankful to you, sir. With this, I would like to hand over to Dr. Subbarao for taking us forward. Thank you.
Thank you, Alok. And greetings to our senior most, Amitabha Ghoshal Saab, for being here with us today afternoon. And as he said, sparing his valuable time. He's a doyen of our profession, one of the most reputed consultants in the country. And his reputation is something so amazing that we're happy to have him here with us today. And he's celebrating for the CEAI, of which he's the president. As you can see in the backdrop logo, its 60th glorious year. So we're very happy to have the president of Consulting Engineers Association also here in this capacity. Mr. Amitabha Ghoshal is presently Chief Advisor to the Board of Directors STUP Consultants. He is the president of Consulting Engineers Association of India. He has a rich experience in the management of design office with large manpower and having personally set up more or less the entire division of STUP in Calcutta. He has worked on various overseas projects in countries as varied as the Middle East, Southeast Asia, and Africa, overseeing design consultancy and project management consultancy in sectors such as highways, railways, ports, harbors, industrial structures, infrastructure, urban planning, water supply, drainage systems, drainage treatment, and wastewater treatment, buildings and township development. So that is his wide area of expertise. And we are indeed very fortunate to have someone of his eminence and his stature with us today. The topic today that he has chosen is a beautiful one, something which I'm sure at the end of the event will weld us all together in our bridge community and in our structural and civil engineering community. On that note, may I make a few small announcements. First of all question and answers. All question and answers shall be answered only if they're in the Q&A box in the bottom of your screen. If you have joined by phone, they will be in the top right hand. So only questions in QA box will be answered, not those in the chat box. Certificates, if required, will be on you ask us and we will send it to you, but for which we will verify your 90% attendance based upon our time assessment of your presence in the event. At the end of the session, after the written questions in the Q&A box are addressed, then we will if we have time, we will do a hand raising and persons may ask their questions by raising their hands, which you can see and do so. Thank you. Ghoshal Saab, floor is yours.
Thank you. Thank you, Dr. Subbarao, and thanks Mr. Alok Bhomik, President of IAStructE. You all thanked me for accepting the invitation. You see, not many people would come to me for giving such a lecture. So it's a pleasure for me to share my knowledge with all of you and the participants. As President IAStructE mentioned, CEAI is celebrating its 60th year, and we are going to have, just as a consulting engineering association should have, we are going to have a set of webinars on the basic tenets of consulting engineering, and culminating with hopefully a live celebration sometime in February, courtesy Corona, if she disappears from the screen. Otherwise, that will also have to be on a virtual media. Well, the subject, the theme that we have chosen, I think it is very, very good of IAStructE to have agreed to this theme and rather thought about this theme, because these have been the beginning of bridge engineering by Indians. You know, it is a learning process, and I will explain to you what good it has done to the Indians. Okay, I will move to the screen. Give me a second. Not very adept at such things. Let me first. Good idea. Good idea. 17 নম্বরে আছে, 1 নম্বরে যাও, ব্যাক করে যাবে, তুমি তো 17 আছো। Right. Okay, sorry for this slight delay. You see, the title, as IAStructE has decided, is Brief Historical Review of Howrah Bridge, the first long span bridge in India. You know, this is a bridge which, as everybody knows, has been an icon of Calcutta. And for that matter, all over India, people recognize this bridge on its view. And there have been films made with the name Howrah Bridge, not one, many. And any film which shows Calcutta, somehow or other will be showing these bridges with some opportunity. So the city awakes with the bridge, and it is there for the work day, and at night, you know, for celebrating the 75th year of the bridge, Calcutta Port Trust, who still oversees this bridge, decided to make a lighting arrangement. You know, the bridge keeps on changing color at the night. So this is a part of city nightlife, and anybody wants to see Calcutta by night will have a view of it. You see, when we talk about bridge, a bridge is just not an infrastructure. I don't look at a bridge, and I'm sure you also don't look at a bridge as a mere structure made of steel or concrete. A bridge is essentially a link not only between two places, but it links two separate settlements, two separate group of people, and then bring people together. And that is how the bridges are always glorified. If you go to San Francisco, you cannot come out without having a visit to the Golden Gate. There have been books written on Golden Gate, you know, poems. And in London, the Tower of London Bridge is a prominent presence. Nobody has thought about dismantling that, even if it is a very old structure. Similarly, in Calcutta, I hope nobody will think of ever dismantling this, because this is part of Calcutta and its development. You see, people celebrate anniversary of individuals and marriages, and sometimes even, you know, we remember people after their death. And we also celebrate anniversary of organizations, just as we are celebrating 68th year of CEAI. But engineering structures are taken for granted. Nobody usually think about an engineering structure unless it falls or gets damaged, or it gets into news for some wrong reason with an accident. But an engineering structure reflects the toil and sweat of the engineers, our community. And it is the fruition of a lot of effort that we see a structure built and completed and successfully maintained and being utilized. I congratulate IAStructE for this initiative to celebrate this engineering marvel, and it is my hope that they will repeat such effort with other so many interesting structures in the country, which shows the capability of the engineer. Now, a little bit about Kolkata. Kolkata was founded more than 330 years back, in fact, and it was just a trading port on the eastern bank of Hooghly. You know, the famous East India Company that came to Calcutta, came to India as a trader, then ruled over it for, started a colonial ruling for 200 years, had been trading in India more than 350 years back. And Calcutta happened to be one of their main trading ports. So they sent a official, Job Charnock, who came over to Calcutta, came along the river Hooghly upstream, and then liked this place because it had a lot of draft, lot of depth of water, and water was still because it was more than 80 miles above the confluence. Even if tidal effect was there, it was not that strong, and therefore he decided to settle down with a port in Calcutta. And very interestingly, he chose the eastern side of the river, even though the mainland India is on the western side of the river. He chose the eastern side, which was marshy, which was full of disease, mosquitoes, which still are there as colonial heritage. But he decided to build it in this side, most probably thinking of the marauders who would come from the mainland and will try to loot their ships. The river was a natural barrier, and that's why he put it in Calcutta, even though the Howrah on the other side was a much older habitat and used to have a regular life and regular settlement. All the supports were available on that side. Even then, he decided to settle for Calcutta. Now, Howrah being on the western side, connected to the rest of India, got the first railway terminus. For both, railway was private those days, for Bengal Eastern Railway and also for South Bengal Railway. Both of them had terminus in Howrah, which are now Eastern Railway and Southeastern Railway. And the rest of India, people who are coming to Calcutta to be a part of this trading community, had to come to Howrah. Now the traffic grew. In those days, most of the transport used to be done on the river because it consumed least effort and one could easily pass along the river routes. And people used to cross the river on ferry boats. But as the traffic grew, not only humans, but also, goods, because trading was improving, East India Company was flourishing. They were taking away goods from India and bringing finished goods to India. So all the time, the river was busy. And therefore, it was decided that there should be a bridge across the river. How to build a bridge on a river which has got tidal flow 4 times a day, and the water rises by more than 20 feet, more than 7 meters in the when the extreme tide comes. So it was decided that they will have a pontoon bridge on floating pontoons. The road would be put on that, contagious pontoons, and there will be a removable central section such that the trans-river traffic could flow. I hope I am audible all right. Now this trans-river traffic grew, and the first temporary old bridge was commissioned in 1874, and it was designed by a very famous engineer called Sir Bradford Leslie. He got his knighthood because of the bridges he built. He built the Jubilee Bridge also. And when he designed, he declared that this bridge is for 25 years. But it had to serve till 1943, which is almost 70 years, till what would be called the new Howrah Bridge was inaugurated. What we know today as Howrah Bridge was known as New Howrah Bridge in those days. Well, this is the pontoon bridge. Very interesting spectacle. You can see a steel truss in the front, which is for allowing the watercrafts to pass through, the smaller ones. And you can see the traffic along the bridge is mostly horse-driven chariots, bullock car-driven goods vehicles, or human-pushed vehicles, and of course, colorful Indians crossing along the footpath. Now, here is another view. Even in those days, traffic jam was known. You can see when the pontoon bridge opened up, as you can see here at the center, the one piece of the bridge has been taken out. Has been taken out, and it is floated out, making the bridge discontinuous at the center. And all the big watercrafts used to pass through this gap. And during this period of opening, traffic would build up on both sides, and what we today know as very common spectacle of traffic jam, that was there very much. Next. Now, whatever had been built in 1878 was also proving to be inadequate because of, number one, this business of traffic getting stopped when the bridge is open on the road, and when the bridge is closed, the larger watercraft could not cross along the river. Then there was this tidal variation 4 times a day I mentioned. So not only the water rose, it also made the approach slope, what was normally designed for 1 in 40 or 1 in 35, used to vary from 1 in 15 to 1 in 25. The average slope was 1 in 35, so that bullocks can take across and humans can take the load across. But then this will go up or down during the high tides, and some of these vehicles would not be able to cross. Then the overloading due to pedestrian crowding and movement of vehicles, they also made the pontoon sink by up to 2 feet or 60 centimeters, causing disruption in traffic flow. There'll be a jump with a lot of vehicles come, the pontoon will sink, and the adjacent pontoon will cause a little difficulty for crossing. So people started searching for an alternative, how to solve this problem in the river. A committee of engineers was formed, previous page, however. Well, there was a government of West Bengal, or Bengal, not West Bengal, I'm sorry. They formed a committee, and they told that committee, these are our problems you have to solve. Next. So they formed a committee of engineers, and they invited internationally alternative schemes, but more or less based on floating bridge principle. But there were conditions given: no obstruction in river channel, boats must flow all the time, minimum headroom of 29 feet from the highest water level, so that boats can cross, and the carriageway width of 60 feet. In those days, it was a very, very futuristic thought. plus footway of 10 feet on each side. And the gradient should not go steeper than 1 in 35 anyway, so that our friendly bullocks can cross the bridge. The design load was given, and this prize money of 3,000 pounds, which was enough to attract a large number of entries. 22 bids were submitted, and the German firm MAN, which still exists, was adjudged the best and awarded the prize. However, already there was rumbling that this business of floating bridge cannot be a permanent solution, because one day or other a river craft will come and hit the so-called floating pier, and the bridge would be damaged. And then this variation of tide would always be there. That's the reason. So therefore, this was, even though the prize was given, the entries were all discarded. Then a new committee was formed. The president of the then Institution of Civil Engineer UK was appointed, and he recommended an arch bridge. Obviously, he did not have idea about the Calcutta soil. Now, this was automatically rejected because of the inadequate foundation strata. And meanwhile, First World War came up and then interrupted further progress with the bridge. Now, for a span, the port has already decided they cannot afford to have a pier or an obstruction in the river, so that their flow of goods are not anyway disturbed. So they wanted a bridge which will be 1,500 feet or 457 meters, single span across the river. Now, what are the alternatives in those days for this type of bridge? One is suspension bridge, which had been built already in USA with rigid anchor, where you have the cable anchored into rock or in some permanent sort of structure. Arch bridge, like the Sydney Harbour Bridge. Or the third alternative was the balanced cantilever bridge, which two of them, very famous, had just been completed. One is Fort Bridge, which is the first major balanced cantilever bridge, and then the Quebec Bridge, which was also a successful balanced cantilever bridge. That can be done with on soft soil as well, because the loads are always vertical. Now again, activities were started after the First World War, and that's the time when a new committee was appointed under the chairmanship of Sir R.N. Mukherjee, Sir Rajendranath. He was the first president of Institution of Engineers that came to being exactly 100 years back, 1920. And Sir R.N. Mukherjee was a persona to reckon with. He had established a firm, Martin Barnes, which built the Victoria Memorial, the Belur Moat, and so many other structures, and was considered a very, very successful engineering company. And he was naturally was the first president of Institution of Engineers. And this committee that was formed, if you remember the colonial times, this was a committee where the chairman was the Indian, and all the other members were very famous Caucasian engineers, mainly from England, one or two from Europe. And that's the committee which was presided by Sir R.N. Mukherjee. Now, Sir R.N. Mukherjee's committee went through the process, and they made a very, very thorough analysis of what is possible and what is not possible. And he came forward with a solution for the permanent solution for the Howrah Bridge. Just to indicate how important was Howrah Bridge in those days, the Institution of Engineers, what you are seeing is the first volume of Journal of Institution of Engineers, brought out in 1921, and it had an article on a Howrah Bridge problem by one Mr. Bagley, who of course advocated very strongly about the floating business. Now the design parameters for the long span bridge, again, same clearance of 29 feet above the highest water. The founding soil being clay and silt, minimum load on foundation, and the waterway below the bridge had to be kept open during construction to allow river traffic moving. The approaches had to be kept to a gradient of 1 in 35 to the maximum, but what the bridge offered is 1 in 40 and made the life of the bullock much better than 1 in 35. Well, today's Vidyasagar Setu, the second Hooghly bridge, has got approaches which is 1 in 25, but the old bridge has 1 in 40. That's why it is so easy to get onto the bridge. The road carriageway was decided as 71 feet between curbs, and that could accommodate 8 lanes of breathe-in traffic. Even today, it accommodates, as per our present code, it accommodates more than 6 lane carriageway of traffic, and it had 15 feet wide footpath. The future vision that those people had, they could see that with the Howrah station so close and the central business district growing on just on the other side of the river, umpteen number of people coming from the suburbs will be crossing the river, and that's why they provided a footpath of 15 feet. Now this decade, very interestingly, is identical with the Vidyasagar Setu, which was built in late 20th century, 1993, I think it was opened. It also has exactly 100 feet total width, including the footpath. The design of superstructure for 1500 feet in those days naturally raised a lot of debate and discussion. Various alternatives were examined, and even after the official design was done by the consultants, Rendell, Palmer and Triton, RPT, which has ceased to exist and had become High Point Rendell for some time. Now, next. They came forward with alternative. Now, this was the scheme which was recommended by Sir R.N. Mukherjee's committee. You can see the wisdom. It is almost same as the bridge that we have today. It had a 1500 feet center span, of which at the center is the suspended span. And the anchor span on both sides was 350 feet, anchored by dead weight on the end, so that the lifting would not be there when the cantilever, which is much longer, comes into play. And those cantilevers from both sides support a hogback truss, which is the suspended span. That's why we call it a balanced cantilever suspended span. Then the other alternative was a self-anchored suspension bridge, which should not require a static anchor, which should have a girder as a deck, which itself will act to balance the horizontal thrust and will be able to accommodate the bridge without causing much horizontal thrust on its foundation. The third alternative was based on floating bridge principle. Incidentally, same designer, Sir Frederick, he came forward with this design, where he provided intermediate trestles on floating pontoons and give a permanent clearance, 29 feet at the highest high level, and therefore river craft could pass, as also could vehicles pass by giving different slope onto the spans. And the fourth alternative, of course, what we see today, more or less, the cantilever, balanced cantilever suspension bridge with some modification from the official design. You can see that hogback hogback truss. Go back to the previous. You can see that hogback truss, apart from this, has been replaced with a horizontal surface, and I think all of us agree that it gave the bridge a much better aesthetic look. Next. Now, this is the basic principle of that balanced cantilever bridge. You can see the anchor spans on the side. You can see the cantilever, which are slightly tinged green. And you can see the suspended span of 564 feet being held in position at the tip of the two cantilevers. The cantilever span was 468 feet. The anchor was 300 feet. So as it is, there is an overturning moment, and plus the weight of the suspended span, and that required at the end, at the anchor, very heavy concrete blocks, 27 feet by 54 each, 2 numbers, and going to a large depth, so that the bridge does not topple. And the other interesting thing, you can see that the deck is hanging from the truss. The truss bridge is holding the deck, which is hung from vertical hanger, and the approach spans, the anchor spans, are kept open so that the vehicles could take a turn and go to the bank. Unfortunately, by the time the bridge was being built, a lot of structures, including the first mint in the country, first mechanized mint in the country, has come up just behind the Calcutta end of the bridge. And that's why straight flow of traffic was not possible. So traffic had to take a turn, right angle turn, to go to the bank. Now, based on this official scheme of rental permanent return, Port Trust decided to invite global tenders, but they were wise enough to keep a provision that the tenderers can offer alternative design, that is EPC scheme, engineer, procure, and construct. A contractor was given the freedom to choose his option and give an alternative scheme which will be examined and valued. Obviously, there were two intentions. One, whether a cheaper scheme can be obtained. And the other, I think the consultants fully agreed with that, that by having alternate design by renowned constructors, they will get their official scheme also proof checked without paying any money. Anybody who is going to court will first check the official design and then examine how it can be made more economical. Now, 4 bids were received. There were 3 bids. There were both the places bids could be received, either at the London office of RPT or at Calcutta at the Port Commissioner. Now, 3 bids were received at London, one from a British firm, one from a Scottish firm, and the third from Germany. In Calcutta, there was one bidder, and that's a new kid on the block, the Braithwaite, Byrne and Jessop Construction Company, which had been just formed for quoting for the bridge. All of them were fabricators, not bridge builders, but they were supplying steel materials for bridges. And they decided that this is an opportunity. We are all located at Calcutta. Let us, instead of competing with each other for this project, let us pitch our strength and try to quote as an Indian entity. Now, the Indian part, of course, all these companies were owned by Britishers, but Britishers were located in India. And the British firm, Cleveland Bridge, which quoted from Britain, was the Britisher from UK. So by that time, the flurry, the sort of trappings of the independence movement has already come and had also been affecting the Britishers, because they could see that once India gains independence, the emphasis would be on getting it from the firms which are local. Atmanirbhar, they would try to be. And that's why they decided to give a serious bid, and they appointed who was afterwards known as Sir Ralph Freeman. He was not yet knighted, So Mr. Ralph Freeman was appointed as a consultant by Braithwaite Byrne and Jessop to give them alternative design. And Mr. Freeman gave 6 alternative bids. 3 of them with official superstructure design and 3 of them with alternate superstructure design, but all of them with alternative arrangement of foundation. And of course, they quoted one on an official design also, so that they are not thrown out. When the bids were opened, the German bid by Krups was found to be complete and financially the lowest official bid. The bids by BBJ actually were financially lowest, but the alternative bids. But the alternative bids were all rejected, either on consideration that they have suggested foundations which the consultants considered not to be convenient or feasible. And so far as the superstructure alternatives are concerned, they were considered extremely futuristic and untested. Mr. Freeman came forward with the concept of grid deck, orthotropic deck, and he came forward with hybrid solution that the top cord of the truss from the tower was replaced with cable. So the suspended, in the cantilever portion, the top tension member was replaced with cable. So it was a hybrid solution with cable and structure. Now all these were rejected, and therefore Krups, of course, was shelved because of political reasons. It was already, war clouds were there. It was 1938, 37, and it was decided that it will be too risky to give it to a German company, which of course proved to be correct once the war broke. Now, the work was awarded to the bidder from Great Britain, Cleveland Bridge, a very famous bridge building company, but all the same, the Braithwaite Byrne and Jessop didn't like this. They made tremendous lobbying, and the Chamber of Commerce, Bengal Chamber of Commerce, took over the cudgels for them, and even the Viceroy got involved, and ultimately a solution was found where it was decided that the contract will be given to Cleveland Bridge, but with a stipulation in the contract that the entire fabrication work will have to be subletted to BBJ to be done at the local shop. Well, it was looking back on hindsight, it was a win-win situation because the local industry got what they wanted. They got fabrication of 26,500 tons of heavy steel work. And for Cleveland Bridge, all the hassles of bringing steel, fabricated steel from UK all the way through sea, and where German vessels would be moving around trying to torpedo them, would be avoided. So BBJ, when they got the work, they wanted to prove their work, and they produced really excellent international class workmanship. So much so that a length of more than 300 feet, the entire anchor span, they assembled, and the error was found less than 2 millimeters. I mean, that is the type of workmanship that they produced, which had been lauded by the designers and by the people connected with the bridge. Now, the benefit of this decision was that the engineers and workmen from India who received this training, that ensured that in future no major steel bridge has been done from outside. This Vidyasagar Setu, when it was conceived and when it was being tendered, it would have been the longest cable-stayed bridge in the world, because the nearest alternative was 350 meters, and this was 450 meters. And that courage of quoting for the longest cable-stayed span when we have not done a single cable-stayed span came because they were confident that whatever they take, they will be able to build. And ultimately, of course, BBJ built that bridge, but slightly different design from what they had tendered for. Now, this Howrah Bridge was giant leap forward for the Indian engineers who had to take over the responsibility for of development work in the country. And the workers also got baptized in the process. Next. You see, as I was mentioning, the fabrication, this is quote from the paper of Howard and Shirley Smith. Shirley Smith is a very famous bridge engineer and had penned books called The Long Span Bridges of the World. This is the quote: fabrication was very good and suffered in no way from being carried out in 4 different shops. For example, a careful check on the full length of the lower cord of the anchor and comprising of 8 members showed that it was correct to within 5/64 inch of in an overall length of 325 feet. Now it is more than 100 meters. In 100 meters, the error was less than 2 millimeters. Next. Now, even the foundation work, I will come about the superstructure later, was considered unique. It again, particularly those coming from Mumbai, including my moderator, will be happy to know that HCC, the Hindustan Construction Company, did the foundations in those days, and what was, and even today will be considered a unique foundation concept. Instead of going for separated foundations, as we did for the Vidyasagar Setu, for the 2 towers, here for the 2 verticals of a tower, one common foundation, cation foundation, rectangular, 182 feet by 81 feet, comprising of 21 chambers, 7 into 3, I will show you a picture, 3 on the width side, making that 81 feet, and 7 on the longer side, making the 182 feet, was pitched and dug in the river bed to a depth of 87 feet on Howrah side and 103 feet on Calcutta side. And in Calcutta side, because there was fine sand, which was prone to blowing, they had a problem of blowing, and this was anticipated, and they had to do work with compressed air, again an unique thing in those days, with 3 times the atmospheric pressure. People used to go down and do the inspection with decompression chambers, and it's the first time this compressed air work was being done, and there were cases of bent disease to the workmen because of non-familiarity with the do's and don'ts of a compressed air work. They did not have the mandatory waiting time which we give today when we enter into a compressed air chamber. Next. This is the schematic drawing of the foundation. You can see 7 across and 3 on other side. This is the plan, and on the top is the elevation. And the whole idea was to simultaneously grab from 21 chambers so that the entire colossus mass goes down without any tilt and shift. And the foundation was installed without any recognizable tilt or shift. It was within a couple of inches when it was set, and both the foundation, and there was no question of any corrective action. Again, the wisdom of the planners and the designers showed in the conception of the foundation. Next. The superstructure erection, at site had to be done without any support from the river. It was not allowed to have any giant cranes on the river. So the bridge was designed right from the beginning based on cantilever erection, so that the bridge will come out from the bank, cantilevered out, and will be completed. And this 26,500 tons of steelwork were fabricated in the works of Braithwaite at Khidirpur, Jessops at Damdam, and Barnes at Howrah on both banks. And single pieces were up to 60 tons, and these were transported by railway line, which was specially laid along the river, and they were brought near the bridge from where cranes were lifting, custom-built cranes were lifting them, and the crane which erected also was lifting the materials, sometimes from the river, sometimes from the bank. And all these steelwork from the three fabrication shops were assembled in another shop called Victoria Works next to Braithwaite at Khidirpur, which was laid out only for assembly of the bridge structure. It was long for the bottom cord to be laid, and they used to fit all members, including the gusset, before they were dispatched to site. The towers, which were 300 feet high, were erected. I will show you how the erection was done. They first started erecting from the anchor span, and from the tower went back to anchor span, and then it came to the cantilever span. Cranes were specially designed, called creeper crane or crawler crane, which could tackle the varying slope of the top girder. It could climb at a steeper sort of slope of the anchor span, and then coming to the inner span, the slope would keep on changing, lastly becoming horizontal, and the crane had arrangement with jacks so that it could be easily adjusted, and the crane platform was always horizontal. And this entire erection of 26,500 tons of steelwork, its fabrication, assembly, and erection was completed in 41 months, 1938 to March 42. And please don't forget, these were the years where war was on. There was scarcity everywhere. There were problems. War emergency was there, and bridge was not the topmost emergency. Now, you see, I will show you the construction drawing. This is how stage one. You see on the bank, the creeper crane is in position, and both sides, and they are going on building the anchor span. Next, this is from there, from on top of the truss, they built the tower, and then once the tower was completed, the crane decided to topple over from one side to another side by adjustment and by using its own power. And no problem. They crossed. After crossing over, it started cantilevering. You see, this is how the cantilevering started. Next. You can see it's like a meccano, gradually moving forward, and the slope of the crane is getting changed, altered regularly. And finally, they will come and build the anchor span. The anchor span was also the suspended span, I'm sorry. From the cantilever span, it was cantilevered, and the suspended span was done, and then the bridge was complete. Now it has come to the closure. Well, it looks like a meccano, looks like a baby's play, but in reality, it was not really always that. But the engineers concerned had made meticulous calculations of all these stages at the time of designing the bridge. They did not wait for the contractor to find out how he is going to build it. It was their responsibility to see that the bridge can be built. And when you can see, when 750 feet of steelwork is cantilevering from 325 feet of anchor steelwork, there will be huge amount of dip. And here was also that dip. But for that, they had built in arrangement inside the top cord, where the cantilever ends and the suspended span starts. They had built in adjustable jacks so that the span can be lifted. They had also incorporated arrangements at the anchor at the ends so that the span can be lifted. The entire structure can be lifted. So they made calculations so that the shortening of the bottom chord and the lengthening of the top chord, which will happen with cantilevering, are catered for in fabrication. Even then, when the central closing was there, things did not really go forward as easily as was thought, because the temperature of the day was different from the temperature on which basis the fabrication has been done. And therefore, ultimately, for the end bottom closer, they had to use heat so that there is expansion. They had to heat the cords, and then when they came together, they made the closer. And as you can see, after the truss has been done, they started erecting the deck. On the left and right, you can see the hangers are being put and the deck is being completed. Next. You see, I had been given an hour. I suppose the moderator and the president's time is not included in that. So I have a little more, just about 10 minutes to finish.
Go ahead.
Yeah, please go ahead, sir.
Okay, you can see some of the old pictures of the bridge being built. The anchor span, as you can see, was built on trestles, giant trestles, for which they had installed Frankie piles for supporting that load. And you can have a look at that crane, that marvelous crane, two of them, on the roof, on the top, there's a cross girder on which there are two cranes for erecting the two trusses. And they were moving up the slope and going down the slope, up the hill and down the dell they were going. Next. You can see it is just crossing on the left picture. And on the right picture, they have come over on this side. And cantilevering is going on. You can see the river flows unhindered. Of course, the pontoon bridge was still there. It could not be disturbed because it was still providing for all the traffic to flow. And then, you see, this is another picture. You can see the Howrah station on the back, on the top picture. That is the Howrah station. Not much change till now. And this is the completion picture of the bridge, where all the four cranes, they have done their duty and they got dismantled after erection of the deck. You can see the part of the deck done, and after completing their duty, they got dismantled and brought back to the deck. Next. And the bridge is open to busy traffic of man-driven vehicles and bullock-driven vehicles, and of course, horse-driven chariots as well. You can spy some old automobiles, the T4s and the very old trucks which had just been commissioned. The bridge even today looks the same. I will come to that later. This is one of the erection pictures. This is Indian workers. You can see Sardarjis, they are very much active, and 300 feet above the river, they are happily erecting, joining the pieces and trying to get them the holes faired before they can do the riveting. And this is what I call the baptism of the Indian workers. This young boy who is hanging at the front, facing my side, he was Omeruddin Khan, who became the foreman of BBJ afterwards. And when Mukama Bridge was built, he was the foreman. He was the sort of very, very respected by the bridge construction staff. Everybody used to call him Bada Sahab. And he used to be there just to give his presence. And he taught a large number of workers. The second Hooghly Bridge was built by Harban Singh. The Hardinge Bridge repair and the second Hooghly Bridge was built by Harban Singh, who used to be a tea boy for Amruddin when he was doing Mokama. They trained them personally and sort of chided them to do the work. Next. You see, what I have always found is fascinating, the way work could be done those days. The concreting was started in November 37, and the plugging was completed in May 1938. 7 months, 8 months, those two caissons, giant caissons that you have seen, and foundation was ready. Anchor steelwork started from November 38, and the deck steelwork got completed in March 1942. And the bridge was ready for traffic in August 1942. But very interestingly, the bridge was opened to traffic only on 3rd February 1943. Those who are interested in history perhaps will be able to understand why the bridge had to wait for 6 months before it was opened. August 42 was the August Kranti movement. And from 7th of August, this non-cooperation movement started and violence started on the streets. And that is why no celebration could be held for opening this grand bridge. No formal opening was there. Ultimately, on the 3rd of February 1953 at midnight, one tramway, electric tram, was taken across the bridge, and that was the opening of the bridge, unsung, unheard. And from next day, the bridge was put to use. And of course, because the Japanese bombers were very active at Howrah at that time, the bridge was immediately put under balloon barrage. Large helium balloons were put on the top of the bridge so that the bombers could not stoop down to bomb the bridge. I still recall my childhood days, when I could see from the roof those balloons, and we were always tempted to get those balloons. Now, the other interesting thing about this bridge was the sourcing of materials. Now, 26,500 tons of steel, and mind you, special grade of steel. A steel nobody has used till then. The steel specification was BIS 153, which is still today we call mild steel, which used to be IS 226 and now 2062. I think now it will be called 250 grade. That was the only construction material which was available. But then, here, knowing that this is such a large cantilever, the designers had decided that unless they can use higher tensile steel, the tonnage will be too much. It would have become more than 40,000 tons if ordinary steel was used, and that would have delayed the work. That would have also made it much more cumbrous. So the so-called high tensile steel, which we came to know as IS 961, and BS was BS 548, and even today is known as grade 350. That type of steel was specially used. The only place where that grade steel was being used concurrently, was the reconstruction of Chelsea Bridge, suspension bridge. And they took the cue from there. They asked all the steel manufacturers in England to experiment in manufacturing of this steel. And the designers drew the specification of the steel. What would be the component of the steel? What would be the percentage of various components? And they asked them to try out. And at the same time, the Indian steel manufacturer, there was only one, Tata Steel, Jamshedpur Works, they got very, very activated, and they decided that they must get this steel manufactured in India. So they took the challenge. They started making the test manufacture and submitted to the consultants, and ultimately they became successful. Out of 26,500 tons of high-grade steel, 23,500 got delivered from Jamshedpur, saving all the cost of transport, all the cost, risk of bringing them from abroad and rejecting afterwards if the quality does not suit. Now, this was an amazing feat, and this was possible because Indians were still nationalists. People used to feel that they must try to uplift the prestige of the country, which fortunately we don't have to do today. We do not need to be nationalists, we can be politicians. And all the other materials, even the cement was Dalmia cement, sand was brought from Damodar, and stone aggregate came from Pakur. And I will show you the physical property of the high tensile steel, which were, sort of submitted for testing. And you can see that home steel means steel made in UK, and the Indian steel is what was made in Jamshedpur. And you can see the yield stress is slightly better for Indian steel, and even the sort of elongation percentage is also better with the Indian made steel. And that's how they own the game and got the order for this 23,500 tons of steel, which perhaps many in Tata Steel has also forgotten today. Next. Now, we did a little checking, a little research of how that the bridge is so agile even today, and there have been no damages anyway. The design specifications for this deck, what they had done, the design load given by the consultant at 488 kg per square meter, that gave a total loading of 4825 tons on the deck. And if you take IRC 6, allows 6-lane class AA, and we will get a deck load of 3984 tons. Now, instead of 4825, even today, the design load, if we design this bridge today, it will be less than 4,000 tons. So that leaves us a margin still. You can say that this was a wastage. They have unnecessarily over-designed, but I would say that this they have saved for the future. This is foresight which has gone in the design specification. Next. Look at the bridge. This is a recent picture from the bottom, taken from the bottom. The deck and the stringers. Unfortunately, it was not orthotropic because that was not accepted. These are stringers are simply supported with expansion. Next. And this is how it looks from the bottom chord of the truss, not the deck. This is the bridge truss ends here. This is the bottom chord. And another thing you can notice that every diagonal has got a arrangement for climbing, for maintenance purposes. And look at the heavy, the top chord did not have any top lateral bracing because it was a cantilever truss, and it will be permanently in tension. And therefore, the tension part, the cantilever part did not have any cross bracing, but they provided stout cross bracings at the verticals. You see, that is how the geometry has been maintained, and these bracings, which we tend to ignore these days, we often try to omit, and at the cost of the stability of the bridge, had provided this bridge this capability. And everywhere for maintenance workers, provision had been kept so that people can climb. And of course, that had a negative effect. People out of mind, deranged people often climb the bridge and go to the top and say that I am the king of Calcutta. Next. The other interesting thing, I had just passingly mentioned that there are adjustments made provided in the bridge in case there is either a settlement of a tower on either end, in which case the bridge will become sort of will have developed a kink. So they made provision in the anchorage adjustment so that the structure could be pulled down at the anchor level and the tip of the cantilever can be raised. You see, they had provided anchor girders. As I mentioned, there were 2 anchors under 2 trusses, and they had 2 verticals. So there is this grillage girder, and they have provided adjustable tacks and 16 hydraulic jacks for each anchor. So 64 jacks have been provided, and they are still available for use. And this arrangement, is something which they have done so that the bridge can be erected successfully. And if ever settlement happens in the clay foundation, that could be taken care of. Next. You see, these are some of the very special arrangements which have been there in the bridge. You can see on the right the suspended stand, which is just supported on the cantilever tip. And you can see the use of pins, large pins, so that the free movement of the bridge is there. You can even see a pin on the top of the vertical, which is the hanger for taking the deck. Even there a pin is provided so that the expansion and movement of the deck does not get transmitted to the truss. And then you have a jacking arrangement by which one could pull the girder when this complete closure came. I mean, these were the gadgets which were used. Next. This is another one. You can see the gadgets. These are all recent pictures, and they are in that upkeep. You can look at the rivets. They look perfect, absolutely. And, probably I am being too partial to the old age, but okay, I can afford that. And these are the movements. These are the gadgets which are provided in the bridge for future use. And you can now understand the wisdom of having 15-feet footpath. This is a normal day. People are returning to catch their train at Howrah station, the day workers. I mean, it is the same scene as you perhaps see in Victoria Terminus or Chhatrapati Shivaji Terminus at the end of the day. And the bridge is full. And you can understand, why the bridge is still being loved. What are the special features of this structure? One was, right from the beginning, emphasis is given on the aesthetics, not only on the elevation. If you see the towers, they have been flared out at the bottom, not for any structural reason, but, utilizing the material fully, but that profile has been given so that towers look attractive. The travelers and the pedestrians get view of the river and the city bank because they are traveling along the hung deck, and that allowed all the sort of dirtying and all the sort of environmental degradation that people can do to a bridge has been taken on the deck, not on the truss. Easy to climb, I have told you. This was the first major bridge in the world using high tensile steel, and this is the first major bridge in the world using principles of pre-stressing of girders. The girders, the cords, compression cords have been lengthened, the tension cords have been shortened, and the joints have been kept true to the geometric design, and that's how the pre-stressing have been introduced, and that had allowed the secondary stress to be away. The bridge gets its perfect shape when the maximum dead load and live load is there. Well, the bridge came up at a time when domination from UK was being resisted, fought on the streets. And the bridge reflected an expression of the Indian zeal to take things in their own hands. That's how Tata reacted. That is how, the engineers, the workmen all reacted. And it has been built with Indian money and been maintained with Indian money, because every Indian citizen who comes to Howrah pays a small cess on the railway ticket. If you buy a ticket from Howrah to Delhi, it will be less than Delhi to Howrah. Similarly, every Calcutta citizen and Howrah citizen pays a small percentage of the municipal tax towards the bridge maintenance, and the bridge is maintained with that fund which accumulates, and Calcutta Port Commissioner who maintains the bridge has got a complete team of engineers headed by a deputy chief engineer to maintain this bridge. Well, I will finish my talk by showing you the excerpt from a recent book on bridges. I just came across, somebody sent me. It reads, you can't read it, I will read it. It was opened for traffic in February 1943, and like all great bridges, helps define the city in which it stands. It now has spectacular sister bridge across the Hooghly, the Vidyasagar Setu, which is a 823-meter long cable-stayed affair opened in 1992 and incorporating a maximum span equal to the 457-meter span. But there is no question which bridge is most beloved in the city and which remains the source of greatest pride and sense of identity. I am a Calcuttan, so I also feel proud. Thank you very much for listening to me.
Thank you, Ghoshal Saab. Thank you very much for a most amazing presentation, filling us with pride and joy of what Indians can do and what they can achieve when they take the cudgels and take up pride in their work. Profession of engineering is greatly enlightened by your expose and treatise on what is really a wonderment, which is our Howrah Bridge. On this, I can't tell you how many questions have been asked and how many expressions of gratitude and identity and solidarity with pride for an engineer are being addressed by the chat box as well as the Q&A. So we're very grateful to you. Some of the simple questions that we may ask is, I just epitomize because it's not possible to individually ask. Our past president of the Institution of Engineers, IEI, Mr. Ashok Basa is amongst one of the audience. So you've got luminaries in your audience to asking questions. So the first question summarizing is, what is the protection method that is currently used? How is the bridge maintained? Is there any special paint, or what is the maintenance regime? That's the first question.
Can I answer now?
Yes, sir. Yes, sir.
Shall I? Yeah. You see, as I said, Calcutta Port Trust has got a separate unit for maintaining the bridge, headed by a deputy chief engineer and assistant engineer and some workers. And the bridge had been provided with a trolley underneath, which was a hand-driven trolley in those days. With that slope, they used to roll a winch, and by that winch, they could go along the slope of the bridge and go to the other side. And those people used to come to work every day looking after the deck. I have myself climbed on that trolley when they had a problem with the with some people had been pouring milk through the expansion joint to Ganga Maya, and because that was the only point from where you could pour milk on Ganga Maya easily, and it corroded. Milk is a corrosive material. It corroded the end of the stringer, so I had been asked to come and help. So I went and saw that joint on climbing on that trolley, and there would be a team which is working. There will be painting every 3 to 5 years. There would be people climbing on the girders to see if anything has gone wrong, if anywhere, birds start making cages. And as I said, they had provided for facility for climbing. This giant bridge, 300 feet high tower, you could go to the top of tower with a little plaque. If you don't have vertigo, it was not an issue. And recently, the bridge was checked for, the rivets were checked, and very few rivets, very small percentage of rivets had to be changed. That restoration work was also given to BBJ, who did the work some 10 years back. And the bridge, as it stands now, in my mind, it can easily survive for another 50 years, no problem.
Right, sir. So Mr. Mal is also expressing his gratitude as a past president of CEAI, and there are so many people who are asking questions or even giving praise. So let us stick with the technical part. One very important question: have those hydraulic jacks, which are used for the realignment and adjusting of the profile, have they ever been failed, or have they been replaced, or what is their status?
You see, I am told that the jacks are still in working condition. They had been only used during the construction. It was not necessarily used because there had been no settlement whatsoever in the tower. Right. But at the time of closure, when the central joint had to be done, they had to be used, right, for tilting. Right. And that is how the joint was done.
Right, sir. They're not used today for adjusting any profile.
No, not necessary, today, because the bridge is in perfect shape.
Right.
75 years of settlement has made it iron,
Right. Any idea about any load testing that was done to qualify or requalify the bridge in recent times? And the other question, I'm just summarizing because there are excellent questions being put and continuing to be put. There are 72 questions at the moment. So from the chat box in the Q&A. The other point is about the seismic resistance, how that was, it is in a seismic zone area, Calcutta, and it was not specifically designed for it as such.
Yes, it was.
It was.
It was. The design specification has given the coefficient of G/16.
And that was taken care at that time.
That was taken care, but the wind was stronger. So bracings were basically designed for wind. And that was the, and as you know, because the weight was very much below the tower. So just like a suspension bridge, the problems of seismic was reduced because the CG of the bridge was much lower than the top of the tower.
I must, Dulal Golder Saab has asked Professor Dulal Golder where the material testing was carried out at that time.
Of course, it has been carried out recently also.
Right.
Of course. When you test a bridge, naturally you have to test that.
The material as well, right?
Yeah.
I might add, I studied at Imperial College, and in the archives of our library in the civil engineering department are all the test data and material, huge amounts of qualification, checking and analysis are stored in our archives at Imperial College. So I happened upon this one day, and as you can get every piece of material. It is so meticulously documented and stored, even today.
You see, they believe in documentation. All that I can talk on the bridge is from the papers, 2 papers which were presented on the 15th August of 1947. You see, they, instead of civil engineers, had the lecture on Howrah Bridge on that day. And those papers are invaluable. That's what I always say, that we, today's engineers, we don't document what we do. We ourselves are not proud of what we do.
So
that is why we get kicked around.
Correct. So the other question that is being asked is there any structural health monitoring system in place? And are the Calcutta KOPT actually looking at the monitoring? Are they documenting the change in status of the bridge with time?
You see, as I mentioned, about 15 years back, there was they were appointed, even the RPT was involved. But it is not anymore the same RPT, but rights and CES also involved in that inspection and testing. And for special repairs, etc., I had been involved as BBJ and also as STUP. When I left BBJ and came to STUP, when this repair work came up, they gave the job to STUP for doing that inspection and testing. But systematic testing as such is not done as a part of the routine. But as I said, special appointments have been done and special tests have been done.
The question I think that was, sir, is there's no specific in-place structural health monitoring system, sensors, etc. installed at this time?
No sensor. Right. No sensor.
Right, sir. And you might add, sir, some special features of the bridge which you have listed. and which show the robustness and resilience of this bridge so many years of use and abuse, I would say. But
Yes.
the foresight of the engineers at that time,
Yeah.
the planners and engineers at that time, are what is today lacking. I mean, it's a comment for you to just pick up on.
Yeah.
What are the changes that engineers and planners need to take away from the study and insight you've given us on this bridge?
You see, I would say that whenever one designs a bridge, a designer has got the responsibility to see how it will be erected. A designer has also got the responsibility to see how it is going to be maintained. It should be a part of design award, a scope of the designer.
Right.
And which are the part of the bridge which requires careful maintenance.
Right.
And here, that principle had been followed because the documentation, I could, just as you have found out from archive, I could find out from BBJ's archive, the 6 alternatives which have been submitted by BBJ.
Right.
Somewhere tucked in the godown, it was there. I got
Lovely.
at least some of the papers out.
Wonderful.
When I was involved in designing the second Vidyasagar Setu, second Hooghly Bridge, BBJ as a part of EPC, BBJ was preparing the design, so I got involved along with Freeman Fox. And at that time, I studied this bridge thoroughly because I wanted to know how did the old bridge in 1940s and what should we learn from there. That is how I have been quite familiar. And I am trying to pen a book on Howrah Bridge.
Wonderful.
Francis and Taylor has made a contract, but I am failing miserably. I am not able to, I have just been able to complete 4 chapters out of 8. Let me see if I can finish it within the revised contracted time.
And it's not like we can say we will help you, sir, with that, because the knowledge is with you, the material is with you, and it's what you've observed and is in your head. So none of us can even volunteer to help. Look forward to that book. Please do give it to us. Please do make sure that it comes out. We look forward to it.
Thank you.
Other point that was raised, sir, just a couple of questions, and then I think we will answer by email. We'll log and answer by email. It's coming up to 5:30. Sir, the issue is that of fatigue, and fatigue as a phenomena was not so well understood at that time in civil engineering structures, and why the rivets were used. I think they're allied questions, the use of rivets and the fatigue issue, and the accumulation of fatigue over time, because the live load has changed to what it was originally envisaged and designed for. The type of live load has completely changed to highly vehicular and highly densified type of vehicular loading. So is there a study for fatigue to be done? Would you consider that this should be done for this?
You see, there are a couple of things I could not show because of the because of the limitations on time. I have got this, I showed you the steel result, but I have not showed you the steel composition. You see, one thing is it had 0.36% of copper, and it had a liberal dosage of chromium. That is why the bridge has corroded the least. Excepting for the deck, which is used by pedestrians. They have, of course, used it as toilet, being Indians, and it is also a thriving market for people going back. So they sell vegetable on the bridge, and those wastes get accumulated. That is how the bottom of the hangars were getting corroded. And what now port commissioners have done has built concrete protection against that.
Right.
So that people just cannot abuse it as much. And the main truss, as I said, is much above. So it is not accessible to the to the humans who can do it. And the foundation also, we made some research. My colleagues did some work. The foundation bearing pressure, whatever. At that time, there was no soil mechanics, hardly any. So we used the data collected by AFCOM for doing the tunnel under the river. And on that basis, we calculated the bearing pressure, and we found out that the bridge has got 10% margin still on the foundation pressure.
Amazing.
So it has been blessed with still capacity in the foundation and capacity in the superstructure.
Amazing. So resilience, just to add,
yes,
I think resilience Robustness and resilience are embodied truly in this bridge.
Yeah.
Apart from the joy that it has.
And sorry, one more point. You asked about rivet. What else than rivet could they use at that time?
Correct.
Because bolts cannot be trusted.
Correct.
There is not a single bolt in Howrah Bridge. That's a popular quiz. They ask how many bolts are there in the Howrah Bridge. You know, the rivets were only safe material to be used. And the other thing they did, because there is a mix-up of mild steel and high tensile steel. So they have made the high tensile rivet different shape than the mild steel rivet, so that the workmen do not confuse. Now, these are the care which you need to take.
Very true, sir. Very true, sir. I mean, we could go on because the questions are continuously coming in along with, salutations of congratulations.
Well, I can only say I am grateful to Institute of Structural Engineers for inviting me. And it has been my pleasure.
So just two
And
announcements.
I feel very excited with old bridges. I have worked on Hardinge Bridge, the restoration of that bridge, and it had given me great pleasure. When they celebrated the century, Bangladesh celebrated centenary of that Hardinge Bridge, and they specially invited me, the technical advisor to the Prime Minister invited me. And, I was taken to the site by a special train called the Centenary train.
Yes.
And they make a lot of pride about it.
Very true. We just attended an event in Bangladesh online, and this was spoken about. And Saiful Amin.
Saidul,
The point.
Yes, IAStrucTE there. He was the secretary at that time also.
What I want to do is to give the Q&A box and the chat box for you to take home, because we couldn't deal with it. But I can assure the participants that these questions could be answered. I think about 90% have been automatically answered through the presentation and in these discussions. And if there is anything, please write into IAStructE. We will reply every question. I hope this event encourages you to become members and share and grow with us in this wonderful profession which we call structural and civil engineering, especially bridge engineering. And there are few announcements which Alok will make about our future courses, to which we will invite you. The last point I would like to say is to you, my friends, take pride in your work always. We as engineers are the forefront of everything that human beings live with in the built environment. If we don't do our work diligently and with robustness and resilience, as has been shown, demonstrated by that bridge, the habitation of people around it will not be at peace, cannot be at peace, and growth and prosperity can never ensue if you have a weak link. So our job is to build good links always: social, economical, commercial, and cultural ties, which is what this bridge embodies and does. That is my message. Thanks. Thank you, Ghoshal sir. From my side, I am humbled and I'm absolutely amazed by this presentation. Alok, over to you.
Thank you, Dr. Harshvardhan Subbarao, for this fantastic closing remark. And thank you for moderating this session pretty well. I profusely thank Amitabha for such an amazing and excellent presentation. One of the comments which I just want to share with you, which came in the Q&A box, is some lady thanking COVID-19, which has helped her to attend this wonderful webinar. You see, very rarely, in fact, very rarely, we can gather more than 400 people in an event, physically when we were conducting them. Today, we have more than 400 participants, and I don't know how many are participating in the live, transmission. Total, it was 1,385 registration. So on the whole, I once again thank you, Mr. Ghoshal, for this wonderful presentation. And I'm sure many people have requested that, and I think the speaker himself said that we should have more such presentations of our bridges, glorifying, we should take pride in what we do. And I think we will surely try to organize more such webinars highlighting the work which we have done in number of other iconic bridges. Coming to the IAStructE program, I just want to
Please share.
mention that we have a lecture series, a course on cable stayed bridge, which will start from 5th of September. It is a long course which will be spread over 14 days to 2 days a week till 17th of October. And I, I think anybody who is interested to attend this course may please contact IAStructE for the links. It will be given by Professor Holger Svensson, a very well-known, renowned bridge engineer who has written an excellent book on cable stayed bridges. So with this, and we also are going to have a short course on fatigue to bridges that will be organized sometimes in the October, in the month of October. With this, I would like to thank you all participants, and thanks to the speaker, Mr. Ghoshal and Dr. Subbarao. Let us close this session. Thank you.
Thank you. Thank you. Thank you.